So to factor a difference of squares, the first thing we need to realize is, well, what is a difference of squares? Now, in general terms, a difference of squares is two perfect squares, like a squared and b squared, where we are taking the difference of them. And by difference, we just mean subtracting. So an example of something that is a difference of squares would be something like this, x squared minus 16. Okay, so the first term, x squared, that's a perfect square, that's x times x. Negative 16, or rather 16 is a perfect square, that's 4 times 4. And then this is a difference because we have a subtraction sign. Okay, so to factor this difference of squares, x squared minus 16, all we do is we need to figure out, well, what's the square root of x squared? Or what times what equals x squared, and it's x times x. Then we think what times what is 16, that's 4 times 4. And then we make one of these a positive and one of them a negative. Okay, so we can check this by multiplying out. X times x is x squared, x times negative 4 is negative 4x, 4 times x is positive 4x, and then 4 times negative 4 is negative 16. The middle terms cancel out, and we are left with what we started with. So to factor x squared minus 16, this is what we would end up with. Let's look at one that's a little bit more challenging. So again, this is a difference of squares because 5x times 5x gives us this first term. 3 times 3 gives us the second term. So factoring this, we need to figure out what times what is 25x squared, and it's 5x and 5x. What times what is 9? Well, that's 3 and 3. And then one of these gets a plus, one of them gets a minus. We'll do one more here, y to the 4th minus 16. Now this doesn't quite look like the others, but this is still a difference of squares because y squared times y squared gives us y to the 4th, and 4 times 4 is 16. So factoring this, we need to figure out what times what is y to the 4th. Well, that's just y squared and y squared. What times what is 16? Well, that's 4 and 4. One of these gets a plus, one of them gets a minus. Now, we're not quite done because this first binomial is, again, a difference of squares. Each term, y squared and 4, are perfect squares. So this one's going to factor into another set of binomials. Y squared is y times y. 4 is plus 2 minus 2. Okay? And then the second binomial from above, that cannot be factored because that is not a difference of squares. While each term is a perfect square, it's not a difference because we have a plus here. That's a very common mistake, to see something that is the sum of squares and to treat that as a difference of squares. So this would be the final factored form here.